We are facing a climate emergency, and immediate actions need to be taken to prevent the deterioration of architectural heritage. Depending on when they are located in the world, buildings are affected by extreme temperatures, increased precipitation, or desertification. Overall, it is expected a global warming of 1.5 Celsius degrees by 2052. Greenhouse gas emissions from buildings contribute to this increase of temperature, and considering that buildings and construction account for nearly one-third of the global energy consumption, we need to ensure that we intervene in buildings in a way that emissions are reduced, but without damaging their architectural values and significance. Adequate architectural conservation, which includes energy considerations, is vital to address the challenges of climate change. How will historic fabrics then react to rising temperatures and increasing storms? Traditional buildings are more sensitive to climate change because they are more porous, more direct contact with the ground, and facing an increased number of freeze-thaw cycles. Timber and other organic building materials are also subject to increased biological infestation. Increases in storminess, extreme precipitation, and wind can lead to structural damage. They also force population to migrate as the sea level rise, there is desertification and flooding. There are also air tightness and condensation issues that affect buildings. Unfavorable effects of changing climatic conditions produce that archaeological evidence buried in the ground could be lost rapidly if the stratigraphic integrity of the soils were to change as a result of changes in precipitation and increased floods. Some properties listed as cultural heritage are built in coastal lowlands, and increased sea levels and coastal erosions could threaten their conservation. Most of the strategies to reduce energy consumption of buildings focus on the installation of new energy efficient systems. What is, however, fundamental is to analyze and understand the existing fabric to minimize the need for extra systems. We need to understand the implications of the location of the building, its construction materials and technologies, how it has changed its use and systems, including heating, cooling, and ventilation. We have to consider, for example, that a heat loss in a typical home is 10% through windows, 15% because the droughts, 15% through floors, 25% through roofs, and 35% through walls. We should align the principles and practice of conservation with sustainable design principles. Remembering also that material conservation is an inherently waste avoidance activity. We should improve the energy efficiency of the built heritage without compromising its architectural and cultural significance.